Yes, we don't do a lot of linear in grade 11, but we will see it again a little bit in grade 12 if you guys take grade 12. So it's good to remember the linear relations and the linear equations, okay, and how to graph them, okay? These are things that will not go away. So what's a linear relation?
Is this?
So what, like, how would a linear function look like? How would it look like on a graph? Since I'm saying it's a linear function.
It looks like a diamond.
That would be, what's the diamond? Diamond is the absolute value.
Yeah,
It's a straight line, yes. It is a line. It's just a line. It's just a straight line. It could be, I know, this is one of the trickiest questions, even though the easiest question, right? Because it's so easy. So equation, linear equation looks like a straight line. It could be either increasing, it could be decreasing, right? It could be vertical. This is so not aligned. It could be horizontal, right? So it could be any one of these shapes. It's a straight line, okay? Now, do you guys remember? What's an equation? What would be the general equation of a straight line?
Y equal bx plus constant.
Okay, so we use here mx plus b as the constant. Yes, but you have the idea, yes. Okay, so we use the, do you guys remember that y equals mx plus b? Does it ring a bell at all? Yeah, y equals mx plus b. That's one way that we can write linear function. We'll talk about that in a bit. Okay, y equals mx plus b, and this is called the slope y-intercept form. Okay, slope y-intercept form. We'll talk about that in a second. Okay, but the other general form of a linear function is the following. It's ax plus by plus c equals 0. When things are not aligned properly, they drive me nuts. Where a has to always be positive. Okay, we always force a to be positive. Okay, and is represented, so a linear relation, which is, this is the standard form of it, is represented by a straight line. That's the graph. Okay, so one way, there's three methods that we use to graph linear functions. Okay, one method is by finding the intercept of a linear equation. Okay, so let's look at, for a second here, let me add the page. If I have, do you guys remember what these are called? What do we call this? The XY grid, right? This is the XY grid, or Cartesian plane. So there's different names for it. So this is the XY grid. Or Cartesian plane. Okay, and on the Cartesian plane, you can find points, right? What goes on this side of the Cartesian plane on the x numbers? These are the positive numbers, yeah? So 1, 2, 3, 4, 5, and so on. And then these are the negative x values. Then on the vertical line, which is the y values, I have the positive y value, and I have the negative y. Okay, so you can find points on the Cartesian plane. Okay, so if I say 0.53, right? If I give you 0.53, a point goes x find your points on the Cartesian plane. Are we okay with that? I don't know if I should review these things or not with you guys, but I'd rather be safe than sorry. Okay? Because you're going to have to actually graph points later on. Okay? So if you have, let's say, point -4, 2, where do I go first? X is -4.
And the y to up to.
And to the 2. Okay? So that's -4, 2. Okay? Remember alphabetical order, X, Y. Okay? Now, if I have, okay, I want that. If I draw a line, oops, that's a very bad line. So if I draw a straight line, okay, you see that my line is going to intersect both axes, the x-axis and the y-axis, right? So if I'm looking at this point here, and I'm looking at these points, these are my x and y intercept, okay? This right here is the x-intercept, right? Because it's intersecting the x-axis. And this right here is called the y-intercept. Are we okay with that? Now, if I'm looking at the x-intercept, what is this point here? It's a point. Point has to be x and y, so it's going to be -3.
-3.
Yeah,
Minus
-3. And what would be the y value at this point?
I don't know.
What's the y value at this point here?
0.
0,
Ah, okay.
right? So because you're on the x-axis, your y value is 0. Yes?
Yeah.
Now, if I'm looking at this point right here, pretend this is 4.5. What would this point be?
4.5. No, 0.
0 as the x,
4.5.
4.5 as the y, right? So if you're on the y-axis, your x is 0. Okay? So if I'm going to find the x-intercept, always, no matter where it is, right, the x-intercept, y is going to be 0. And if I'm going to find the y-intercept, no matter where I'm intercepting the y-axis, the x value is going to be 0. Okay? So I need to know this information. So, the x and y intercepts of a linear relations are where the line crosses the x-axis and the y-axis respectively. Crosses the x-axis, y-intercept crosses the y-axis. To find the x-intercept, I set what to 0? What? Set y equal to 0. Okay? Because remember, x-intercept, y is 0. And solve for x giving coordinates, so it's going to give me point x 0. Okay? So my x-intercept is going to look like this. A value of x, so 5, 6, 9, minus 2, plus 1, whatever, and then the y value is going to be 0. The y-intercept, what do I set to 0?
X.
And solve for y giving coordinate
0.1.
0, comma, y. To draw the linear relation, plot the x and y intercepts and draw a line between them, like a straight line. that. So the question is asking graph 2x plus y 6 equals 0 by determining the intercept. Now looking at this, 2x plus y minus 6 equals to 0. Does that look like ax plus by plus c equal to 0 to you? Right? With a, b, and c are actually constants, right? Numbers. They're numbers. Good. Now, if I'm determining the intercepts, that means I have to find the x-intercept and I have to find the y-intercept. To find the x-intercept, I set y to 0. So to find the x-intercept, y is equal to 0. So I am replacing 0. So that's going to be 2x plus 0 minus 6 equals 0. Are we okay with that part? Okay, so I replaced y with a 0. Now I'm going to have to isolate for x. Remember what we did yesterday by isolation? Right? The two-step or multiple-step isolation. So first let's 0 minus 6. 0 minus 6. It's going to stay the same, right? Negative 6. So what do I do to isolate for x? Move what to the other side? Move the negative 6 over. What does it become when you move it over?
So x equals 3.
And divide by 2. So the x-intercept is 3, 0. Are we okay with that? Okay. The y-intercept, what do I set? Set x to 0. Okay. So in this case, I'm going to replace x with a 0. So it's going to be 2 times 0 plus y minus 6 equals 0. Two times 0 is 0. So it's going to be y, take away 6, equals 0.
So y equals 6.
Bring over, y equals 6. So that means my point or my y-intercept
0, 6, right?
So what I want you to try right now, try to locate these points and let's see, make sure you use a pencil just in case. Try to locate these points on the graph and let's see if they match where I'm going to put them. Do you guys have... So where does the 3, 0 go? So
Y is
here,
that's
here, here. Okay. 3 on the x, and then it stays on the x, right? And then for the y-intercept, which is 0, 6. So you see I have 2 points. I can literally just like draw a straight line doing them. Remember, this is not aligned properly, so look at this. And then we always put arrows at the end of the lines, okay? Arrows means it's continuous. That means it doesn't stop here, okay? It's gonna keep going, right? So that's why we put the arrows at the end. This is not an X, these are arrows at the end of the, you can extend the line as much as you like. Okay, so that's one method, finding the x and the y-intercept by plugging in 0 for y and 0 for x. We're good? Now, anytime, no matter function you have, okay? If you want to find the x and the y-intercept, you just plug in 0, right? If you're finding the x-intercept, you plug in 0 for y. If you're finding the y-intercept, you plug in 0 for x. So no matter what kind of function it is, the process is the same. It gets harder to find the x-intercepts as you have higher exponents, but it's still the same process. The other method is by completing a table of values. Okay? Completing a table of values is probably your way when you're stuck and you're really, really stuck and you don't know what to do, how to graph. This is your method of escaping that and then trying to find a solution. Okay? So, a set of ordered pairs. So ordered pairs means points. Okay? Ordered pairs means points. Okay? Which means that they're x and y. Okay? So a set of ordered pairs can be determined by completing a table of values for a linear relation. The points can be plotted and graphed, okay, after you find the values. So your equation is y equals 3x plus 2. How do you know something is linear? Other than looking at the equation and then making like it's ax plus by plus c. What else? What tells you that something is linear?
Yes, the exponent is 1.
The exponent is 1. Okay? Important that the y exponent is 1, right? Otherwise we have circles or whatever, right? But also the most important thing is both of them, both letters, have an exponent of 1. Okay? So you see that it's not visible, right? So your exponent, your degree is 1. Okay? That's how we know this is linear. So using a table of values, that means I'm going to have to set up my table of values. You set up x and y. Okay? Then if you want, you can add another table, another column here that includes the point, if you want. Your x values for linear, you can always use -2, -1, 0, 1, and 2 for the x. For linear, these are the points that you can always use, no matter what function you have. So the x values are set values. Okay? Now, how do I find the y?
I will replace x each point in the equation.
Yeah. So x is -2. I'm going to replace x with a -2. Remember, this is my equation. Okay? This is my equation. So I have y equals 3, replacing x with a -2 plus 2. Okay? What's 3 times -2 plus 2? The math tells me what do I have to do first? 3 times -2, which is -6. Add 2, that's -4. Okay? So that gives me a point, which is -2, -4. Okay? You're going to do the same for all the other x values. So you have -1, you have 0, 1, and 2. I'm going to leave you to do this, and then we'll take it up.